Hi, PyTech Summit. I'm Ruslan Korniichuk, Ukrainian software and artificial engineer based in Warsaw, Poland. So you can address your questions today in both Ukrainian, uh, even more in English, Polish, and Ukrainian. However, our moderator today, I hope, don't familiar with Ukrainian yet. That's why technical questions please address in English and Polish, and I will translate everything to English, and we will have Q&A session at the end, and I will answer all your questions. Today I want to talk about Temporal. So Temporal is a workflow orchestration platform, and no worries, I will share my slides with you at the end of presentation, so you don't need to take screenshots or photos of slides from the video. And video will be available on YouTube and Facebook. So don't worry, you don't need to record this video today too. I will start with problem statement and explain you why we need this type of solutions. Workflow orchestration platforms like Temporal or Uber Cadence. And next, we will jump to introduction to Temporal. I will present Temporal architecture. Next, I will try extremely deeply explain differences of main components of Temporal, its temporal workflow and temporal activity. Next, course we are on PyTech Summit. I prepared for you a temporal demo, and also I will show you how you can execute the same demo and be familiar with temporal basics soon. And at the end, we will back to slides and start Q&A sessions, and moderator will prepare questions, and I will address all your questions today. Just quickly check chat. Please put something nice to the chat, for example, your location and maybe if you Ukraine also put this one to the chat. And let's start with problem statement. Yes, of course, why we need this type of solutions. And as software engineer, usually we deal with business requirements, and sometimes we need to code some business process. For example, in this case, we have some order. We want to execute fraud check. It means we want to check, can we use payment details from our client, or it's fraud, yep, and we cannot use this payment details like credit card was stolen, for example. And next, we need to check, can we fulfill the order? It means, do we have everything on stock to be shipped? Next, we need to charge our client, receive confirmation of payment, and only next we can fulfill shipment. However, course we need to deal with third-party services, for example, with Stripe for payment. As software engineer, we are responsible for all of these challenges, like error handling, failure recovery. We need to manage state. Probably we will have some database. That's why we need to deal with transactions. We need to deal with events. Sometimes we cannot quickly process API requests. That's why we need to have timeouts. And after timeout, when we cannot talk properly to API, we need to cancel our shipment, and we need to make some compensation, for example, return money to our client because we charge our client. Also, we need to deal with rate limiting. It means some functions of our code maybe can be executed only once. For example, payment. We don't want to have duplicity and charge our client 2 times. That's why we need to deal with rate limiting. And just few examples from real world ideal. Imagine we have API. However, this API is unavailable. Like third-party API, we need to talk like Stripe, for example. And in this case, to process this case, we can easily in Python loop use loop, and we can retry this API. For example, every second. I don't have answer, API unavailable, retry in 1 second, retry in 1 second. In this case, quickly we can go to situation of DOS attack. Denial of service, it's mean for server, it looks like we are doing DOS attack on them. That's why next iteration of our code can be let's increase delay during each iteration of retry loop. It means retry in 1 second, next retry in 2 seconds, next retry in 4 seconds, easily. But next go forward, and API can return for us error. And in this case, we need to deal with compensation. For example, we want to undo some steps already completed. For example, if we have already charged our client. But also can be situation with slow response from the API. It means successful connection, successful request, but we are waiting and waiting and waiting and nothing. It means we need to have timeouts, and after some time we need to cancel our order, and we need to make compensation like return money to the client. So together we can expect complexity. And yes, of course, I have good news for today. We can use Temporal workflow orchestration platform. And Temporal will help us to deal with all of these challenges we can face as software engineers. And as a result, we can expect not complexity, but resiliency. And resiliency means its likelihood of resource ability to recover from damage or disruption. And I will use today this word resiliency. However, because we all familiar with site reliability engineering, you can maybe replace this word to reliability. However, reliability, it's a resource will work as designed. It's a little bit different. Or you can even replace to durability, like resource will continue to exist until we decide to remove it. I prefer for this case resiliency, and I will use this word today. So move further to introduction to Temporal. And Temporal, it's open source. Good news, it's workflow orchestration platform. It's distributed and scalable. It means we can use Docker and Docker Compose, or we can use Kubernetes. Temporal designed to execute mission-critical business logic, like payments, for example, with resiliency. And again, resiliency, it's ability of resource to recover after damage or disruption. For example, API is unavailable or extremely long delay in response from API. So Temporal, it's about orchestration, not choreography. It's about execution guarantee, and we will name it today as Temporal Durable Execution. Temporal Durable Execution. It's more about long-term workflows rather than real-time. For example, about order processing, about infrastructure provisioning, about payments, but not about online gaming or streaming, for example. We have better solutions for this type of use cases. And yes, of course, we have Python SDK. That's why I am prepared these slides, and that's why I'm presenting this topic to you today. Temporal used by well-known huge companies like Netflix, Airbnb, Stripe, Snap, HashiCorp, Box. And we can rely on Temporal community. Even with free open source Temporal, we can address our questions to community, and we can expect some answers and help to deal with Temporal and possible challenges. Now let's talk a little bit about history. So we have two co-founders of Temporal, and one of them started his career in Amazon in 2002. In time when Amazon working on idea, let's split our monolith solution, like binary file, to services, to microservices. And in 2004, Amazon announced published Simple Queue service, Amazon SQS. Next, in 2009, both co-founders worked in Amazon on part of Simple Workflow service. And to be honest, it's not simple. Amazon SWF. Next, one of co-founders, Samar Abbas, worked in Microsoft, and Microsoft announced Azure Durable Functions. And Azure Durable Functions is a feature of Azure Function that lets us write stateful functions in serverless compute environment. So it's serverless stateful functions. Next, both co-founders again worked in Uber, and Uber introduced and published Uber Cadence. It still exists, and we can use Uber Cadence. And sometime later in 2019, finally, both co-founders founded Temporal as company and also Temporal product, a workflow orchestration platform. And also I prepared for you my understanding of evolution of this type of solution. And in the past, products like Camunda ZB, both products still exists and use the same approach of BPMN, business process model and notation. And much easier just to check example from Camunda documentation. So we have prepared blocks, and we can combine these blocks in our workflow, and underneath we have XML. And XML is non-human readable format. So it means we need to use drag and drop approach to prepare our Camunda workflow. Not good one, yep, for us, for Python software engineers. That's why next iteration, I name it DSL, domain-specific language. An example can be Netflix conductor. Let's quickly look on documentation or Netflix conductor. And even we can use Python and Python SDK to code our workflows with Python language. However, underneath we have JSON. That's why in documentation we can find alternatively creating workflows in JSON. So from day zero, from box, it's JSON. And Netflix conductor just translate our Python to JSON. That's how I understand this solution. That's why we can expect next iteration and solutions like Temporal and Uber Cadence. And finally, we can use our programming languages like Python, Go, TypeScript, .NET, PHP, Java to code our workflows. In our case, with Python language. And even more, I can see new one iteration. I don't like this one. Let's name it low code, no code, and solutions like Windmill, Pipe Dream, Retool, Superblock. And why I don't like this type of solutions for my use cases, in documentation you can see, for example, auto-generated user interfaces. And for me, it sounds super familiar. It's like Adobe Dreamweaver from our childhood. Adobe Dreamweaver to build HTML web pages. And personally, I don't want to use solutions like Adobe Dreamweaver for mission critical business logic, like order processing, payments, trading. I want to use something more stable and dedicated for mission critical business logic. That's why personally I want to stay in this area and work with solutions like Uber Cadence and Temporal. And today we will talk more and more about Temporal. Now let's talk a little bit about use cases. So first, a huge group of use cases, it's business process automation. For example, client lifecycle, order processing, and company like DoorDash using Temporal for order processing, or payments, and company like Stripe use Temporal for payments, microservice orchestration, infrastructure provisioning, and companies like HashiCorp use for Terraform the Temporal for infrastructure provisioning, CI/CD, data, and machine learning pipelines. However, my personal feeling for this type of use cases, we can easily use Apache Airflow or Prefect. We don't need to use Temporal. And also Temporal used for engines for low-code, no-code solution. So when with drag and drop interface, we can build our Python applications with user interface, and underneath probably we will find solutions like Temporal, workflow orchestration platforms. Let's move to Temporal architecture next. Let's easily split our diagram to client side and to server side. On server side, we can expect Temporal, like Temporal cluster, and we have different options to communicate with our Temporal cluster. We have Temporal CLI, and we can send commands like execute workflow, or we can start local Temporal server. Also, we have a web user interface like we have with Luigi or with Apache Airflow. And we have our Python application. Inside, we can use Temporal SDK and talk to Temporal cluster. And also, surprisingly, we are responsible for Temporal workers. So it's mean Temporal don't have access to our code and does not execute our code. It's our worker on our side execute the code. And good news, we can use Python to write code for our workers. So pure Python here. Now let's check how looks Temporal cluster. And inside Temporal cluster, we can expect some front-end services, backend services, database, Elasticsearch optionally, and I will talk a little bit later why we need database or optionally also additionally Elasticsearch. On this diagram, we can see all our requests from CLI, from user interface, from our Python application, we will send to front-end services. So we don't have access to backend services or database, for example. We communicate to front-end services. Now let's talk a little bit about the role of Temporal cluster, like responsibilities of our Temporal cluster. So we have worker, and worker executes our code, and we have Temporal cluster, and Temporal manage tasks and history, like history, execution, history. And database in this case it can be Apache Cassandra, PostgreSQL, MySQL, SQLite even. So role of Temporal cluster. First one, manage and tracks tasks related to Temporal workflows and Temporal activities. And no worries, we will talk today about Temporal workflows and Temporal activities. Next, Temporal maintains durably persist event history for each execution. That's why we need database like MySQL, PostgreSQL, Cassandra, SQLite. And Temporal cluster does not execute our Python code and don't even have access to our Python code. Like security feature benefit we can see. So worker execute codes, Temporal manage tasks and history. Let's talk a little bit more about worker now. And role of worker, it's executing Temporal workflows and activities, pulls tasks from and communicates via internet with Temporal cluster, And we can use temporal Python SDK for worker and Python code. And as engineers, we are responsible to configure our worker. And it is good moment to talk about different deployment options. We have multiple options. And option 0, we can use local temporal server. And during the demo, we will use local temporal server. It's for development purpose only because we will have in-memory database. It means imagine we will stop server, start server again, and we will lost all our history, like execution history, like task history. That's why it's only for development purpose. For production, we have two options. Self-hosted deployment. It means we will have self-hosted temporal cluster, and we need to deal with database like Cassandra, MySQL, PostgreSQL. We can use Docker and Docker Compose, or we can use Kubernetes. And optionally, we can use Elasticsearch, for example, when we need to send query and understand status of our workflow. And when we have a lot of workflows, a lot of activities, we may need to have solution like Elasticsearch. And for example, for our help desk, for our support, gives this option to quickly find details about different orders of our clients. If you have a small scale, like one workflow, few activities, we don't need to use Elasticsearch. And second option for production, we have Temporal Cloud. So it's fully managed cloud service, and it means we need to pay to Temporal for this Temporal cloud. We can use open source, free, and self-hosted temporal cluster. And yes, of course, we can use free open source local temporal server. Now let's talk finally about temporal workflows and activities. It's like main two pieces of temporal solution for us, for engineers. And software engineers, usually we deal with business requirements, and it's our task translate these business requirements to Python code and put some Python code to temporal workflow or workflows and temporal activity or activities. And now I will try to explain difference and when we need to use workflows and when we need to use activities. But good news, activity is just part of workflow. So we have workflow with some activities inside our workflow. So workflow must be deterministic. And it means for the same input, we can expect the same output for each execution. For example, in my demo, I will use 2 plus 2. I will execute first time, is equal for second time, equal for third time, equal for. However, when we want to use, for example, randomizer and random numbers, we can expect different result every execution. That's why random numbers is non-deterministic. In workflow, we should guarantee all our code is deterministic. A workflow does not retire by default because we cannot expect any issues with workflow, and workflow can start another workflow. It means we can have sub workflows, and it means every workflow can be both child for some workflow and parent for another workflow. And let's quickly check few examples in Python in area of determinism. And here top we can see non-deterministic code like random.choice, true and false. So it means in one branch it can be for true value, another branch for false. If we want to put this code to our temporal workflow, we need to make this code deterministic. That's why we can use workflow.random.choice, true, false, and workflow is just part of temporal. So we need to import workflow from Temporal in our code. And one more example for dates and time. Now it's non-deterministic, because now and now in 10 minutes it's different now. That's why we cannot use code like this one, datetime.now. However, Temporal prepared for us a solution, and we can use workflow .now. Again, just import from workflow library. So in practice, workflow should be deterministic, and we have some functionality how made this code deterministic. And any operations that introduce possibility of failure. For example, we want to call microservice. Microservice can be unavailable. We want to query database. We want to write to file. All these operations should be done as part of activity. So activity, it's like I can say non-stable with possibility of failure code in our workflow. So we need to wrap everything non-deterministic to activity. Activity retries if it fails, because we have this possibility of failure when we talk to API, to database, or we write file. Activity orchestrated by workflow. It means activity is part of workflow, and activity must be idempotent. Again, crazy word. That's why I prepared for you this one visualization. So code can be executed by mistake 3 times. And at top we can see, let me highlight, example for non-idempotent code. It means if by mistake we will execute 3 times, and our task is payout, we will pay out not 1 million, but 3 million in total. So it's like bad case. We don't want to have something like this one. That's why we need to use for activity idempotent code. It means execute only once. And when we're trying to execute again, but we have already fulfilled, we need to skip. We want to execute one more time, skip again. So any activity can be non-deterministic. However, we need to deal about idempotency. If you want to go deeper with Temporal, I'm prepared for you link to 2 great online courses, very quick, short courses. First one is only around 2 hours. Temporal one-on-one with Python, because we are Python developers. But in practice, in our workflow, we can mix Go code, Java code, TypeScript code, .NET code together. There is no limitations. And second one course, it's around 4 hours, exploring durable execution with Python. So I will share slides with you. You can just will click on this image and navigate to Temporal online course platform if you're interested to learn more about Temporal. And course today we have PyTech Summit. Let's go to Temporal demo, and I will show how it works and how looks Python code. And after the demo, we will back to slides again, and we will have Q&A sessions too. I will address all questions from chat. And in our demo, I will use NBP API, National Bank of Poland, or in Polish, Narodowy Bank Polski. And main idea, we can check currency exchange rate for currencies like US dollar. And in this line, you will find link to demo I prepared. It's, let me highlight, it's public, Temporal PyTech Summit 2024. So let me please open in browser the same repository. And let me double check, you can see the same, right? Just one moment. move back to our browser. So in practice, because we are responsible for worker and we are responsible for workflows and activities, we will have two main files. In this, just one moment. Let's just use this option. We will have example workflow file. You can name it how you want, but Temporal recommend to put code of workflow out of code of your application. That's why we have code of our Python application, we have our workflow, and also we're responsible for worker. And like our business logic, it's National Bank of Poland. That's why we have just one function. Let me increase for you. Get USD rate. It's mean USD to Polish zloty, actual course from National Bank of Poland. And we can use endpoint like this one to collect result. And here we can see how this code mixed with Temporal. Because we're talking about idempotency here, we need to make sure, and async, we need to make sure we use proper libraries. And standard library to send request to API for us as for Python developer is requests. However, in this case, with Temporal, we need to use async safe libraries, and I decided to use HTTPX. And if you want to use external libraries with Temporal, we just need to use this type of constructions. And with this simple solution, we will make our workflow stable, and also we will speed up process of our workflows. So we're sending this request. If everything is good, we want to just check buy rate, sell rate, and effective date, and just return this result. However, if we face some issues, we will retry this function. And when we have errors like 404, we need to time out and stop this activity, because it's not issue with server, it's issue with us, like 404 error cannot be found page, and we can use all concepts from Temporal. So for example, we can raise application error, yep, and we can make non-retriable as true, yep, if we don't need to retry this activity because error is 404. So we talked a little bit about business logic here. But main two files, it's our Python application and our workflow. Let's quickly check our workflow. And we need to use a few wrappers to change our standard Python code to workflows and activities, temporal workflow and activities. For workflow, we use this add workflow.define to prepare workflow definition, and for activity, add activity.define activity definition. And next, as we discussed, activity is just part of our workflow. That's why we have this code execute activity. And here you can see max duration 5 seconds. It means our connection can be successful. Our request can be successful. However, we're waiting and waiting and waiting for result too long. And in this case, best option just stop this iteration, execution, and next retry after some time again, and next retry after some time again. And by default, we can retry unlimited times, and we can change this behavior. And ideally, I want to retry after 1 second after first fail. But because I don't want to make DOS attack to server, I want to double delay after each retry. It means retry in 1 second, next wait 2 seconds and retry, next wait 4 seconds and retry, and up to 64 seconds. Yep, because with this double, we can we faced, I believe, in memes with iPhone block. Yep, so you can block your iPhone to unlimited a period on time, and we don't want to have this logic. So maximum delay it's 64 seconds, and we can just put everything to retry policy and use this retry policy in our workflow. So we have workflow. In our workflow we have something deterministic, like 2 plus 2 it's all time equal to 4, and we don't need to wrap this code to activity because it's deterministic. However, when we talk to NBP, because it's government API, I cannot rely on this one, and I believe you too. That's why we need to wrap this code to activity. Yep, to this one, and use get USD rate. Yep, and in case of fail, we will retry, and hopefully we will get actual currency rate for US dollar. And next question, how we can execute this workflow? Yes, of course, we can use web UI, we can use CLI, but of course we are Python developers. Let's check how we can execute this workflow in our code, and we will use Python SDK. For this reason, let's open app.py file, and here you can see, maybe increase even more for today. And here we can see client start workflow. And this client is our temporal server. And for this demo, I will use local temporal server. And local temporal server will use port 7233. Web UI use 8233. So we will connect to server and we will start our workflow, and we need to provide ID of workflow because ID should be unique for every workflow, and task queue because we will use our worker to serve this task queue. And just remember for future, our task queue is example tasks. And that's it. So we have our normal Python code, and we can start our workflow with Python SDK. And in this case, we will start our workflow here. First, we will execute deterministic 2 plus 2, and next we will execute activity. And here you can see code to our activity. We will get USD rate. It's mean from our nbp.py file. We will execute this code, and we will send a get request to this endpoint and collect information about buy rate, sell rate, and effective day, and just return this result. It may sound and looks complicated, but it's not complicated. One more time, we have our Python application and SDK inside. We need to define workflow. Everything non-deterministic we need to wrap with activities. An activity can be sync or async. And finally, we need to have worker to process all these tasks. And that's why we will have worker Python file here. And code all time looks plus minus the same. Main idea, we need to serve some queue. And previously we found proper name of the queue, it's example tasks. So this worker will be responsible for this workflows and this queue, example tasks. And workflow we want to process, it's hello world. And also we need to put information about activities, and we will use NBP activity, like collect exchange rate for USD. you can put your questions to the chat. I will address your question at the end. Now let's check documentation, and finally let's execute our demo to check how it works in practice. We can install Temporal CLI, and we can execute Temporal server with the CLI. I will use Ubuntu. You can use macOS and it works, or Windows. We just need to download archive with binary. I'm downloaded for AMD 64 processor. Next, just extract binary from this file, and name of binary it's temporal. And next, just put to location like user local bin to be able to execute temporal binary, and with temporal binary execute our server. And for Python SDK, we need to install this library, Temporalio. So we will have CLI, we will have SDK. To start server, we have already learned today, we need to type temporal server start dev. We will have local temporal server in memory database. It means erase everything from memory in case of restart of the server. We will have web UI on port A233, and our application, our workers will talk to temporal based on port 7233, A233. We will execute worker, and we will execute our application, and we can expect result like this one. So now let's check Ubuntu. Yep, it still work. I'm just clone this repository. I have this repository locally. You can do the same because it's public. And let's open one more terminal here and execute our server. So it should be temporal server start dev, I believe. Yep, and now we have our temporal server, 7233 port for server, and for UI web interface we have 8233. We will check this one later, or maybe even now. Just give some time to Chrome. Yep. Localhost 8233, and we can see our temporal web interface here, and we will check a little bit later. Now we need to execute workers to process our code. That's why we need to open one more window. I will navigate to a folder with this code. Just check. We have code for worker, worker.py. Let's execute with Python because it's Python. On this Ubuntu, I have only Python 3. So Python 3, worker.py, and that's it. So it's executed and waiting for some task in queue. As of now, we don't have this task. And we can finally execute our application. Let's increase a little bit. app.py. Yep, and it's not executable. That's why we will use Python 3 app.py. Yep, and finally everything works, and we can see result of our execution. So our app.py started worker. Worker calculated 2 plus 2. Next executed activity and sent request to our NBP API, Narodowy Bank Polski, collect information about exchange rate for today, buy this one, sell this one, and return everything to us, and still our worker waiting for more tasks, so we can execute the same workflow one more time, and we can expect the same result because it's still the same date, and 2 plus 2 it's still equal 4. And now let's quickly check what we have here. We just need to update page, and we have two execution of our workflow. We name our workflow example-workflow, example-workflow. First one execution, second one execution. Just click here if we want to see result. And here you can see the same result, 2 plus 2 equal 4. Buy rate, sell rate, and date. It's today. And here we can see our activity NBP. And most interesting for you, for future, just to understand how all this sync async activities and part of workflows work together, you will find this history, execution history. Worker execution started, task scheduled, task started, task completed, task scheduled, task started, task completed, task scheduled, task started, task completed, worker execution completed. Yep. And our workflow is hello world, and our activity is NBP. And for second execution, we can do the same. Just click any place here and see result of our execution. Imaginate NBP unavailable. It means our workflow will be in progress, infinity, like 1 year, 2 years, 5 years. If we will face only 5 XX errors, but not 404, yes, of course. Yep, we will try to collect data and progress the workflow. And now I believe we need to move to our slides back again. So here you will find a link to the demo in slides. If you want to contact me after conferences, you can use this slide and just click any place here. You can send me email. You can contact me on LinkedIn, on Facebook. Because I am Ukrainian, I should say, please help Ukraine if you have possibility, and you can use this Trusted Come Back Alive foundation. It's still #1 in Ukraine, and from Poland we can easily transfer money, for example, with our debit credit card. I promised you to prepare and share with you slides. That's why now finally you can take screenshot photo of this slide, or you can with your camera just navigate with QR code, or you can just put any place link. It's tiny URL PyTech 2024, capitalized PyTech 2024. And now QA session. I believe we have a lot of questions, and I just need to find main window and find first question from the chat. And first question, can you provide some real-world use cases where Temporal has proven to be more effective than traditional orchestration solution? It's tricky. What does it mean, traditional orchestration solution? If we're talking about Camunda, Zibi, it's more effective for us, for engineers, to use Python code, not drag and drop solution, and XML to quickly write our workflows. And we have scalable and distributed solution, so we can deploy Temporal on Docker and Docker Compose or in Kubernetes. So that's why we can be more effective as engineers, and we can also make more stable, reliable infrastructure, and we can execute these workflows much more faster. When I work with Airflow, at least with previous version, now we will have Airflow 3, I found this huge delay between executions. And you can easily find my talk about data ops, data and operations online or video, and you can find when I presented this insights. Huge delay between execution. So it's not absolutely for real time. And also Camunda Zibi, it's not for long-term processes like 5 years, 10 years. With Temporal, absolutely no problem. And I mentioned today HashiCorp. HashiCorp decided to use Temporal, not Camunda Zivi or Uber Cadence or Netflix Conductor for infrastructure provisioning. Because we need to deploy different resources, change different resources, and we need to have this like business process somewhere. That's ideally we can use Temporal. And I mentioned today DoorDash. Yep, it's like Uber Eats, I can say, or Push.pl, but in United States, for example. And they decided to use Temporal to process orders, not like Camunda Zibi, or Netflix conductor. Again, I believe because it's more resilient, it's much easier for engineers to code and to maintain this one because we have everything in Python. It's more secure because our cluster don't know about our code and doesn't execute our code. It's our responsibility to write worker and to execute worker and process tasks. Yep, however, for cases like continuous integration, continuous delivery, for data pipelines, machine learning, I believe, my personal feeling, let's use cloud native solutions like step functions, let's use Databricks workflows, Apache Airflow, Perfect, etc. My personal feeling. Many thanks. Can we please jump to next question? Second question, what are the main advantages of Temporal over its predecessor, Uber Cadence? I cannot answer this one because it's still my homework to work with Uber Cadence. I'm just analyzed history and people responsible, and both co-founders included was co-founders of Temporal worked in Uber and worked on Uber Cadence. And in documentation, when I searched something for Temporal, I found the same information in Uber Cadence documentation. So I believe they moved a lot of concepts from Uber Cadence to Temporal. So unfortunately, sorry, I cannot answer this question now. I just want to play with Uber Cadence too. I believe in both solutions to find the differences in both. However, Temporal declared main advantages as developer experience. It means for us, for engineers, it's much faster, much easier, nicer to use Temporal. To be honest, I'm not sure about this one because I just need to compare with Uber Cadence and like this resiliency option. Again, it must be touched, but Temporal declares they can execute process like 300,000 tasks per minute, I believe, and they can process more, but they just need to pay more to AWS provider for cluster. That's why they just tested 300,000 per minute, I believe, because we're talking about long-term workflows. We don't talk about like real-time online streaming, for example. But many thanks for this question. Yep, I will test Uber Cadence and maybe even prepare session about Uber Cadence. How does Python SDK enhance the usability of Temporal and other any limitations we are using in compared to other languages? I believe Temporal binary written in Golang. That's my colleagues who worked with Temporal and Go much happier than me. And in Go, we can better and more natively work with sync-async stuff. In Python, we still have a lot of, I don't know how to say it, challenges. For example, I cannot use request library. For this demo, I decided to use HTTPX. Like the same, but code is different. And in request, it's r request dot status, but in HTTPS, it's request dot status underscore code. So we need to deal with all the stuff. We cannot easily moved. So I believe the best option is use Go and go Golang with Temporal. However, for Python community, still we have a lot. And also, cause main co-founder it's ex-Java developer. I can believe for Java it's also super easy to use. And again, you can mix in the same workflow. You can have activities in Java, in Python together. There is absolutely no issue to deal with this. We just execute activity by name, and we will have Java code separately to be executed, and we need to have Java worker. Many thanks, and let's jump to next question. What do you think about API Narodowy Bank Polski? I'm used it multiple times. I have also presentation about technical analysis with Python. Yep, and for my personal use cases, sometimes I just need to have some exchange rate. For example, I am trying to have information about my incomes and profits in US dollar. I believe because I'm Ukrainian, and as Ukrainian, I never relied on Ukrainian hryvnia. And in Poland, still I cannot fully rely on Polish zloty because someday I believe Poland should change Polish zloty to euro, and you can find some pros and cons of this idea. That's why I'm actively using this. I've never faced any problems with this. Documentation looks horrible, but for me personally, it's resilient, reliable enough. And please find my recordings from technical analysis where I'm presented much more different tools and APIs we can use to collect financial data, last exchange rates. And looks like it was last question. Let me check. Yep, I cannot see more. That's all the questions. From my side, many thanks for your time today. I hope I'm explaining a little bit when and why we need to use solutions like workflow orchestration platforms like Temporal or Uber Cadence. And also you have my slides, you can play with demo and better understand the code, understand do you like this approach or not, because we should remember about determinism, we should remember about, I cannot even repeat these words without my slides. However, we also have benefits. We don't need to deal with error handling, with recovery after disruption, a lot of benefits. So one more time, many thanks for your time. Have a great evening. If you like Champions League's football, let's see together great matches together. For example, Shakhtar Ukrainian Football Club will play soon today, this evening. Many thanks and bye.